In 1977, the Voyager 1 space probe was launched to study the outer solar system.
The roll program is in on time. Vehicle response is normal.
After 48 years of exciting discoveries and thrilling adventures through the heavens, Voyager 1 now sends its final message from interstellar space, and the results are not good.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Popular space enthusiasts like Joe Rogan and seasoned veterans like Ed Stone describe the transmission as so disturbing that NASA's officials had to shut down 2 vital parts of the spacecraft just to make sure it lasts long enough to send more information about it.
NASA only confirmed the data on Thursday. Earlier, I spoke to Ed Stone, a scientist on the Voyager 1 project.
What did the message reveal, and why was it so terrifying? Join us as we break down Voyager 1's final transmission before the shutdown and what it means for our understanding of the universe. Voyager 1's final warning. Voyager 1 was initially built in the early 70s to travel through space for less than 10 years, sending back useful data about the gas giants of our solar system, particularly about Saturn and Jupiter. The big day came on September 5th, 1977, when the spacecraft was launched from Cape Canaveral aboard a Titan Centaur rocket.
TVC bus voltage look good, tank pressures look good.
Okay, MDS. Engine program was in on time.
NASA hoped it would last in space at least until the late 80s, but as of today, Voyager 1 has traveled through space for 48 years and is still pushing. Nothing built by humans has ever made it this far, and NASA's leading scientists have been using this chance to find out more about the things that exist far beyond our solar system. But everything changed on March 5th with a troubling warning from the spacecraft. Voyager 1 was barely holding up at this point, and NASA's experts before this believed the next big discovery would be the machine's swan song. With many parts of the spacecraft either worn out or barely functioning, the experts believed this would be Voyager 1's final transmission. However, the new message was so unsettling that NASA's engineers couldn't pull the plug on Voyager 1 just yet. They needed to keep it working, even if it meant shutting down some parts to make it last a bit longer. What was the message about? Well, the answer is a bit complicated, so let's break it down. First off, our entire solar system is covered by a large protective bubble that is formed by our sun's energy. This giant bubble is called the heliosphere, and what makes it precious is that it protects us from dangerous interstellar radiation from beyond our solar system. The disturbing part is that it is much weaker than we thought, and worse yet, it is shrinking at an alarming rate. If it continues at this rate, then everything we thought we knew about the age of our sun, the planets, and life on Earth could have been false all along. Even the most accepted facts, like the age of the universe and the role of dark matter in the cosmos, were now under scrutiny, according to NASA's engineers. This was a huge claim by all metrics, one that puts the future of our species on the line. So what made NASA's experts so sure about this? Now this is where it gets interesting. Voyager 1 discovered this by examining the type and amount of plasma at the far edge of our solar system. This substance is a very hot gas that fills the emptiness of space, and it is frequently sent out from the sun in all directions. The movement of this substance creates what scientists call the solar wind, and it pushes against the more dangerous plasma that comes from outside our solar system. The line where the plasma from our sun stops spreading out forms the boundary of the heliosphere. The parts of the spacecraft that were used to know this were the plasma wave instrument and cosmic ray subsystem. The plasma wave instrument found changes in the density of the plasma outside the heliosphere. It was much different from what the scientists were used to, and worse yet, it kept changing in ways that showed the heliosphere was barely holding up anymore. It was struggling to hold back the forces of deep space, and while this was happening, the cosmic ray subsystem was picking up other unusual things that hadn't been noticed throughout the lifespan of Voyager 1. It measured an absurd increase in cosmic rays, and the energy it came across was so immense that it was as if the spacecraft had just come across the remains of a recently exploding star, and these rays were traced to have traveled towards areas that are much closer than where the heliosphere's boundary was discovered in 2012. Simply put, the heliosphere was growing smaller and weaker, and more of these dangerous rays were getting through at an alarming rate. For decades, scientists thought this boundary was strong enough to keep the most dangerous kinds of plasma away from our solar system. But the data revealed by Voyager 1 showed the exact opposite. The more the spacecraft moved away from the sun, the more the pressure from dangerous plasma increased, and it was much greater than the most powerful solar winds experienced by any spacecraft. This proved that the protective barrier that separates our solar system from natural outside threats was much weaker and thinner than we thought. Many questions flooded the minds of the scientists who studied this. Will more harmful radiation reach Earth in a matter of years? How long would it take? And how would it affect future space missions? These were exciting yet terrifying questions. But before the experts could gather the answers they needed, they faced another huge problem. Voyager 1 was running out of power. Or better yet, the spacecraft was dying, and there was nothing they could do to change that. Keep in mind that this marvel of engineering was built to last for less than a decade, and yet it has beaten all expectations and is just 2 years away from turning 50. So if it had lasted and functioned properly for this long, then why is it suddenly dying now? A good question. Now here is the answer. Voyager 1 runs on a special type of battery called a radioisotope thermoelectric generator. Because of the heat that is caused by how it works, the battery loses power over time. NASA tells us that Voyager 1 loses 4 watts of power each year, and the math shows us that there is no longer enough power to keep all the instruments working. It was a desperate time for the experts at NASA. They wanted to know more about the dying heliosphere to make out how fast it moves and the best way to get prepared for it. But Voyager, at best, had less than 2 years to keep running. That, of course, was not enough time to learn more about the mysterious things that exist beyond the boundaries of the SLAT system. So to make it last longer, NASA's scientists had to make a difficult decision. They shut down 2 major instruments to save battery life, and the first part they shut down remotely was the cosmic ray subsystem. This happened on February 25th, and it was an emotional moment for those who oversaw the operation, especially the ones who had served the longest. One of these experts was a project manager named Suzanne Dodd, an expert who started working on Voyager as far back as 1984. She and others like her had been collecting info about cosmic rays within our solar system through this equipment for over 40 years. But since power was running low, NASA had to choose between full functionality and extending the lifespan of the spacecraft. And to keep getting information about the recent warning, they chose the latter. NASA's engineers wanted the Voyager 1 to last for as long as possible, and by turning off certain parts, they would be able to save power for the most important ones. The hopeful idea is that the spacecraft would keep working with fewer parts to deal with for at least another decade. By then, NASA would hopefully secure the funding for another probe that would do much better exploits than Voyager 1 in much less time over a much longer lifespan. But they know that eventually all its parts would stop working, and when this happens, Voyager 1 would keep traveling through space on its own and would no longer be able to communicate with Earth. It has left us with a long and beautiful history full of exciting discoveries in the world beyond our planet. Let's now take a trip down memory lane to explore some of the biggest discoveries and how they changed our perception of the universe. So without further ado, let's get to it. Pictures from planet Jupiter. Some of the biggest discoveries about the gas giants were made with Voyager 1. Named after the Roman god of the sky, Jupiter has been known for a long time as the largest planet in the solar system. It is so far yet so big that it is one of the few planets that can be seen in the sky without needing a telescope. According to the European Space Agency, all you need is to be at the right place with an experienced astronomer to point out the bright object that looks like the brightest star in the Taurus constellation, preferably during the end of the year. It has been observed by astrologers and astronomers for over 500 years, and even before then, it was seen moving across the sky in a way that made it much different from other stars. But it wasn't until 1610 when an astronaut named Galileo Galilei used a telescope to discover 4 big moons moving around the large planet. These 4 moons were given names a few years later by another astronomer named Simon Marius. He named these moons after 4 companions of Jupiter: Io, Europa, Ganymede, and Callisto. The 4 of them later became known as the Galilean moons, and they were the first items that convinced a lot of people that not everything in space goes around our planet. This was most of what we knew before Voyager 1 was built, and the first images of the planet were captured and sent back to Earth in January of 1979. The closest images were captured on March the 5th of that year, and the details they showed were unbelievable. Based on what the pictures implied, it was clear that the planet was made mostly of gas. Unlike Earth, it does not have a rock-solid surface. But surprisingly enough, most of it is made up of hydrogen and helium, the same chemicals that make up our sun. On top of that, the violent clouds surrounding the planet all come in different colors and are always moving very fast. The fastest clouds produce the biggest storms, and the biggest storm is known today as the Great Red Spot. This storm alone is bigger than our entire planet and has been spinning for at least 300 years. Because of how large it is, Jupiter also has the strongest magnetic field of any planet in the solar system. For other planets, it is like an invisible force that surrounds and protects it from harmful particles from the sun. In Jupiter's case, it is a powerful radiation belt so powerful that it almost destroyed Voyager 1 when it arrived at its closest in early 1979. The clouds are like a blanket of nightmares filled with winds that form white and orange bands that move in opposite directions. While the clouds on our planet are made of water, those on Jupiter are also made of the same thing, but with a toxic dose of ammonia and sulfur. But that doesn't mean the rain is liquid. As you go deeper into the planet, things get a lot weirder. The high-pressure patterns noticed by Voyager 1 in the clouds tell us that it rains diamonds in some places. Yes, you heard that right. It rains diamonds at places that have the highest level of pressure in the clouds. Scientists believe this high pressure crushes carbon into strong, solid materials that fall as hail. Weirder yet, these diamonds won't be able to fall as normal things do, not when winds are blowing over 400 miles an hour. With such force always keeping things in motion, you would have a violent rain of sharp diamonds falling sideways and destroying everything in its path. While Galileo found 4 moons moving around Jupiter, over 95 have been found, mostly thanks to Voyager 1, and the 4 Galilean moons turned out to be the biggest and most interesting of all of them. Named after the Greek maiden who was loved by Jupiter, Io is covered in volcanoes, and like a teen with a horrible case of acne, there are so many eruptions that many scientists see it as the most volcanic place in the solar system. With a lot of sulfur shooting out from the surface, Io looks like a glowing rock with too many spots of yellow and orange colors. Why are there too many active volcanoes? Scientists believe it's because of Jupiter's unforgiving gravity. Of all 95 moons moving around the gas giant, Io is the closest, and because of this, it suffers the most from Jupiter's unforgiving force of gravity. It stretches Io and pulls on it, stretching and squeezing it like a rubber ball. The volcanic formations and eruptions are simply demonstrations of all that, and it won't stop until it completely crushes and destroys Io many years from now. Luckily, the next big moon isn't that unfortunate, and it is none other than Europa. Named after the Greek mother of King Minos and a close associate of Jupiter, Europa is covered in ice with a huge ocean of water underneath. Scientists are sure of this because the pictures captured and sent by Voyager 1 show huge splashes of water erupting from the many cracks on its surface. This body of water is much larger than all the oceans on Earth combined. Some scientists believe life exists in the covered ocean because there is heat at its core. If there wasn't, there wouldn't be cracks on the ice and violent eruptions of water all the time. With the minerals from the core, along with a healthy source of heat and an abundance of water, the ingredients for life are already present as far as the experts are concerned. Because of this, popular science educators like Bill Nye are convinced that there is alien life out there, especially on a moon like this. After that, we have Ganymede, named after the handsome Trojan prince and chief cupbearer for Jupiter. It is the biggest moon, not just of Jupiter, but of the entire solar system. It is bigger than planet Mercury and is the only moon that has a magnetic field. Finally, we have Callisto, the 4th Galilean moon. Named after a beautiful nymph and another companion of Jupiter, Callisto has its fair share of issues it deals with. You see, while Io struggles under the immense gravity of Jupiter, Callisto struggles with destructive forces beyond the planet. It is one of the moons that orbits the farthest from Jupiter, so it is the most open to threats outside, and that is why its surface is full of cracks and deep craters left behind by large asteroids and comets that crashed into it. It doesn't stop there, though. Jupiter has large rings of cloud and dust surrounding it, but they are very hard to see. They are dark and thin, unlike the bright and thick ones that surround the beautiful Saturn. It is also interesting that Jupiter gives off more heat than it receives from the sun. Why so, you may ask? Because the planet is still cooling down from when it started forming almost 5 billion years ago. It is this residual heat that forms the powerful storms and strong winds that would make living on the planet our biggest nightmare. Now it gets even more interesting. As Voyager 1 slowly completed its movement by the large planet, the big difference in the vivid pictures sent back to Earth revealed something quite unexpected. Even though Jupiter is the largest planet in the heliosphere, it also spins faster than any other planet in the solar system. One full spin takes only 10 hours to complete. That's right, one day on the planet Jupiter is only 10 hours long, less than half of what we experience here on Earth. But here comes the mind-blowing part. It was so unbelievable that it got scientists rechecking images from Voyager 1 and other sources over and over again. Are you ready for it? They discovered later that Jupiter is so big and powerful that its gravity also affects the sun. Its strong pull makes the sun wobble slightly as it moves around the yellow star. But don't let the term fool you. This slight wobble is so obvious that scientists today use it to find large planets in other solar systems with advanced telescopes. The sun wobbles like a top because that is just how powerful Jupiter is. And the most exciting part is that many more secrets are waiting to be discovered. It is also surprising to know that the largest spot on Jupiter's surface, initially discovered in more detail by Voyager 1, is shrinking. 100 years ago, it was twice as big as Earth, but now it is almost the same size. What scientists don't know for sure is whether it would disappear entirely anytime soon. And with so many things discovered by Voyager 1 about the biggest planet, it got its last picture of Jupiter in April 1979 as it began to approach the next big planet in our solar system. Pictures from planet Saturn. Named after the mythical father of Jupiter, it was first observed by ancient people just over 2,000 years ago as another bright figure that stood out from the other bright objects in the sky. The big difference is that you can't easily see it in the sky without either a telescope or an experienced astronomer to point out where to look. Nobody knew a lot about this planet until 1610, and even then, the information we got wasn't that impressive. When it was first found by Galileo that year, he thought the planet had big ears. As funny as it sounds, that was the best conclusion he could come up with. This was likely because his telescope lens was not strong or advanced enough to see the rings that circled it. The closest images were captured in November of 1980, and the details Voyager 1 sent back to us were nothing short of breathtaking. First of all, just like Jupiter, Saturn is made of gas without a solid surface. It is also made up of the two gases that make up the Sun and the planet Jupiter, hydrogen and helium. Scientists are not sure whether it has a core or not, and even if they were sure it had one, its size and direct impact on the planet remain a mystery. Planet Saturn is also covered in thick clouds, but the big difference starts with the layers of the clouds so thick that one of them is made mostly of frozen ammonia. It has storms that are more powerful than most of those discovered in Jupiter in 1979, with winds moving at over 1,000 miles an hour. While they are much faster than those in Jupiter, they are also not as colorful, but that doesn't make them less interesting. For one, Saturn has perhaps the weirdest storm in the solar system. What makes it weird? This storm is 4 times bigger than our planet, and it has 6 sides to it like a kind of polygon. That's right, unlike the Great Red Spot of Jupiter that is roughly circular, this large and powerful storm at Saturn's North Pole is shaped like a hexagon. To this day, leading scientists at NASA have no idea why it is shaped this way, and a few of them think it has to do with the way winds move around the planet. What exactly that means and the mechanism behind is still completely up in the air. The powerful magnetic field that protects the planet isn't as strong as Jupiter, but it makes up for that through the beautiful rings that surround it. These rings are bright and make it easily stand out from other planets. They are made of tiny pieces of ice and rock. Some of these lives are as small as grains of sand, while others are as big as mountains. Strangely enough, these rings are only about 30 feet thick in a lot of places, and NASA's experts believe they were formed either from a large moon that broke apart or leftover materials that never formed into a moon. Speaking of moons, Saturn has the largest number of them in the solar system. Back then, Voyager 1 discovered 3 new moons surrounding the planet. They also had special names given to them, and they were Atlas, Prometheus, and Pandora. As of today, there are 274 confirmed moons surrounding the planet, and while most of them are small and irregular, some of them are much bigger and interesting to study. A great example of this is Saturn's biggest moon, Titan. It is bigger than planet Mercury and is covered by thick clouds that make it difficult to see the surface. Just like it is on Earth, most of its air is made of nitrogen. And since the clouds are too thick for us to know what is inside for sure, Scientists guess that it has lakes and rivers and experiences rain. The big difference is that the rains are not made of water. Instead, they are made of liquid methane and ethane. Here on Earth, they are gases because the temperatures are hot. Over there, the extreme cold allows them to exist as liquids. Another strange moon moving around Saturn is another large cold rock called Enceladus. Named after a Titan who once fought Jupiter and his allies, this large moon has a lot in common with Europa. Just like Europa, Enceladus has a frozen surface with large cracks where large jets of water regularly shoot out and create a layer of mist around the moon. Because of this, experts believe that just like Europa,
we do know there is water on Europa. On the surface of Europa, we have an icy crust.
this moon also has liquid water underneath the ice with the right ingredients for life to evolve. Some of the water that shoots out from the surface goes far enough to join the rings surrounding the entire planet and adds fresh materials to them. A few smaller moons are worth looking at, like Mimas, a small satellite that has a large crater that made people think George Lucas's Star Wars universe was real. Named after the giant son of the Titans Gaia and Uranus, this special moon also looked a lot like Darth Vader's Death Star, so much so that it got a few people making up theories about real aliens being the creators of the Star Wars franchise. Iapetus, named after the great Titan and father of Prometheus, has one side that is naturally bright on its own, and another side that is always dark, no matter how the sun shines on it. Leading astronomers describe it as a mashup of two different moons. The Hyperion moon, named after the Greek father of the sun god Helios, is shaped like a potato and has a surface that looks like a sponge with deep craters. Some moons like Pan and Atlas are among the smallest and are shaped like flying saucers because their unique style of gravity allows them to collect many ring materials around their equator. There are also special types of moons going around Saturn called shepherd moons. Their role is to keep the rings the way they are without scattering out of place. They do this by using their gravity to control the ring particles. Whenever one large rock seemed to be going outside the ring, these shepherd moons would drag them back with immense force. As for the few other moons, they work by creating waves and ripples in the rings every time they pass by. They even take turns causing ripples by swapping orbits with each other. As for the planet, Saturn also pulls in frozen objects from space, only to add them to its rings. Now let's get to the good part. Deep inside Saturn is a pressure so high that it causes hydrogen to behave like a metal that conducts electricity and creates the planet's magnetic field. To put it simply, the hydrogen got so good at behaving like a metal that it ended up creating Saturn's powerful magnetic field in the process. Like Jupiter, the planet also gives off more heat than it receives from the sun. The big difference is that it's formed from helium droplets falling through the atmosphere and releasing lots of energy as they get closer to the core. Interestingly enough, even though the planet gives off more heat than it absorbs, the atmosphere is much colder than 300 degrees Fahrenheit, but increases to boiling hell as you go deeper. The planet also spins very fast, completing one revolving in less than 11 hours. This effectively makes one day less than half of what we see here on Earth. Also, since Saturn is smaller than Jupiter, this quick revolving has a much bigger effect on the shape of the planet. Because of how fast it spins, the planet is far from a perfect sphere. A closer look shows that it bulges at its equator and flattens at its poles. Chances are that if it spun twice as fast, it would look more like a squash ball than a rolling sphere. But even though it isn't as big as Jupiter, Saturn has a few other things going for it. This planet's gravity works in a very unique way. It forms and shapes the orbits of many asteroids in the solar system and is most likely the planet responsible for moving the smaller ones into their current positions. Thanks to Voyager 1, planet Saturn went from being a fuzzy ball in the sky with big ears to becoming the most beautiful planet in the solar system. The last picture of Saturn by Voyager 1 was taken on November 16, 1980. After that, its work was done and it continued its journey into the outer solar system without looking back. NASA's experts predicted that the spacecraft wouldn't be able to capture images of Uranus and Neptune with enough detail, so they built and launched another machine to do the job 16 days earlier. And the details it captured were even more puzzling than anything Voyager 1 had revealed. With more exciting discoveries and thrilling details than the last, this other machine was called Voyager 2, but that's a story for another video. So what do you think? How long will Voyager 1 last? Will it last long enough to tell us everything we need to know about the shrinking heliosphere? Tell us your thoughts in the comments down below. If you enjoyed the video, please make sure you like, share, and subscribe. Also, click on the next video shown on our screen. You will enjoy it.